Okay, so can you see my screen?
Can.
All right. Okay, good. Okay, so today we are going to talk about chain rule. Oh, have you heard of chain rule before? Come on, you must have.
Yes, yes.
Okay, so chain rule for multivariable function. Okay, well, so what is chain rule? What's chain rule like? So let's say I want you to look for. Let's say I want you to find dwdt, dy dt. Yeah. Let's say I want you to find dy dt. Okay. So obviously this differentiation only has y and t in the variables. Okay. So what chain rule allows you to do is, okay, it lets you do this process by going through an intermediate variable. So in this case, I may introduce an intermediate variable x. So then what you can do is you can do dy dx dot dx dt. Yeah, to get your dy dt. Yeah, so I go through this thing called intermediate variable. Okay. So this chain rule, you must have done it before, yeah? You must have done it before. I think calculus 1 or something. Okay. So an example. So this is just revision. This is just revision. So example. Let's say I have y equals to, I don't know, 3x to the power 4. Okay. What I can do is I can solve this normally. I can solve this normally. But because the power is outside, what I can also do is I can use the chain rule. So if I want to use the chain rule, basically what I do is I introduce an intermediate variable, maybe u. Yeah. So this u is the intermediate variable. Okay. I introduce an intermediate variable u, and I let it be 3x. Therefore, y is what? If u is 3x, y is what?
U4.
U4. Yeah, right. Right, U4. Yeah. Okay. So what you can do now then is you can du dx. Then we're gonna get 3. You can also equally do here is dy du. Yeah. For u to the power 3. Okay, and then you can multiply the two together to get your dy dx again. Yeah. Okay. So this is what you've done before. This is what you've done before. Okay. Imagine what we're doing today. So again, calculus 2 is always building up from what you learn in calculus 1. So today we are doing the same chain rule. The only difference is I'm introducing one extra variable. Okay, I'm introducing one extra variable. Okay. Do we want to go straight to example? Yeah. Okay. So we are basically introducing one extra variable. Okay. Not now. So let's say I'm going to, so rather than just, instead of just going through the theory with you, I'm gonna go through this theory using an example. Then maybe it's clearer. Okay. So let's say I have a function here. W is equals to x squared minus y squared. X is equals to t squared minus 1. Y equals to t cubed plus t. Okay. So the way you use the chain rule, okay, to solve this is, so let's say I want you to look for dw dt. Okay, so dw dt. So the process is like that. Yeah, you dw dx times dx dt plus dw dy dy dt. Okay, so that's the procedure basically. Okay, so dw dx is what? So again, from your partial differentiation, your PD, if you do dw dx, y becomes a constant. Okay, so what is it? So 2x, would this y squared is constant, so it becomes 0. Okay, times dx dt. So you dx dt here, what do you get? 2t, and then the negative 1 is a constant, so it becomes 0 again. Okay, and then plus dw dy. So now x squared becomes constant, so it becomes negative 2y. And finally, dy dt, this one here. So 3t squared minus plus t differentiate becomes 1. There. That's the solution. Okay. When you have one extra variable. Okay. So, so in theory, the way to carry out the operation is like this. Okay, so you have to draw the tree again. Yeah. So first of all, you need to identify all variables. You need to know what's the main function, what are the independent variables, and what are the dependent variables. Okay. So in this question, the main function is w. Yeah, w. Wait, did I write? Okay, the main function is w. The dependent variable is t. The independent variable, there are two, x and y. Yeah. Yeah. So the independent variables are two, x and y. So it helps you to understand exactly what the process what the process involved is if you draw the tree. Okay. So basically, you have to link the main function with the two independent variables, as again, and also the dependent variable. You have to link all together. So the relationship between w and x is obviously, excuse me, dw dx, and then the relationship between w and y is dw dy. Then from x to t, dx dt, and then from y to t, dy dt. So that's why the solution for dw dt is dw dx times dx dt plus dw dy times dy dt. Okay, so you can see the relationship here. Okay. So let's do one question together. So let's say I have w is equals to x squared y minus xy, xy cube, xy cube. Yeah, x squared y minus xy cube. X is equals to cos theta. Y is equals to e to the power t. Find dw dt when t is equals to 0. Okay, so find dw dt. So again, so to help you understand the process, draw the tree. Draw the tree. So I'm gonna use coloring. I'm gonna use color here. So you want to find dw dt basically. Yeah. So your main variable is w. Your independent variables are x and y. Yeah, I'm using coloring. X and y. Okay, and then your dependent variable is t, and t here is t. Yeah, do you see how I so the first thing you need to do, so whenever you're answering a chain rule type of question, the first thing you have to do is you have to identify what I'm doing here. I'm identifying variables, or rather type of variables. Okay, can you see this, everyone?
Can.
Yeah.
Can.
Okay. So once you identify the variables, then you can do the relationship easy. Yeah, you can link very easily. If w is linked to x, that means is dw dx. W to y, dw dy. X to t, dx dt. Y to t, dy dt. Simple as that. Then the answer is, to get dw dt, to get from w to t, you want to link straight to t. What you have to do is dw dx times, so this term minus the next type, times multiply by the next term, plus dw dy times dy dt. Okay. So from here you use a partial differentiation. So dw dx, how do you do dw dx? So y becomes constant. So what do you get? So x squared y. x squared y. X squared y. You differentiate against x. What do you get? You differentiate against x. 2xy, right?
Yes.
Yeah. And then the next term, x minus y cubed. Well, the y cube is constant. So you just differentiate x. You differentiate x becomes what? 1, right? So the answer is y minus y cubed. Okay, and then dx dt. What do you get when you do dx dt? Well, x is cos t. Dx dt is what? Sine. X is cos t. Dx dt
Sine.
becomes negative sine t, right?
Yeah.
Yeah. Okay. Okay. Someone give me dw dy. So differentiate this w again, but against y. What do you get when you dw dy? Okay. The first one, x squared y, dw dy becomes what? Quick.
X square minus 3y.
Correct.
3y is square x.
X squared minus 3.
3y square x.
Yeah, correct. Very good. And then someone else. Thanks, Hussein. Can I get someone else? dw dt. dy dt. So what do you get when you do dy dt? Yeah, someone else? Oh, this one is easy. E to the power t. You dy dt, what do you get? Ivan, are you there? Ivan? Ada Ivan kan? Yeah. Where's Ivan? Ivan de Mello. Mutang. Where's Ivan? Can you unmute and tell me the answer? Ivan, you there? If you don't answer later on in the attendance, I will mark you as absent. Where's Ivan? Class rep, is Ivan here? No, not here. Hey, Ivan, I see his name. Can I ping him? Cannot ping him. Ivan. Quick. Where's Ivan? If you don't answer, I'll remove you from this class now.
Yes, doctor.
Yeah, I was about to remove you from the class.
Oh,
Where-
sorry. I was washing the dishes. Sorry, doctor.
The dishes?
Yeah.
Following the class.
So, you want me to answer, doctor?
Yeah.
The P exponent T.
Yeah, correct. Yeah, what do you get when you do dy dt?
P exponent T.
Yeah, e exponent t. dy dt, what do you get?
T.
Hmm?
T.
T?
Yeah.
No, I don't think so. Yeah, don't wash the dishes. I'll make sure you're paying attention.
Okay. Okay.
Okay, someone else can help. Yeah. Okay, good. Thank you. Siapa tu? Who is that? Correct. Yeah. So if y is e exponent t, you dy dt, you still get the same thing. Okay, nothing changes. Okay, so therefore e t. Okay, but this is not the full answer yet. Okay, this is not the full answer yet, because then what it wants you to look for is at t equals to 0. Yeah, if you look at the question, look at the question there, find dw dt when t is equals to 0. Yeah, when t is equals to 0. So therefore, what you need to do is you need to find when t is equals to 0. So that means you can substitute t equals to 0 in here and in there. Okay, but you still have x and y. You still have x and y scattered all over the place. So you also need to look for x and y first. Okay, yeah. So when t is equals to 0, what is x? Well, we know x is cos t. We know x is cos t. Therefore, what is cos 0? Because t is equal to 0. What is cos 0? Yeah, 1. Okay. And then y is equals to e to the power t. T is 0. Then what is y?
1.
Correct, also 1. Now you can substitute everything in here. E into t and x's and y's. Okay. So now substitute everything in here. So 2 times x, 2 times x, x is 1, y is 1, minus y is 1, so 1 cube, times minus sine t, t is 0, plus 1 squared minus 3 times 1 squared, e to the power 0. There. So you multiply everything together, you're going to get the answer. Answer should be, I think, -2. Yeah. Okay, so that's how you do the chain rule. Okay. Any questions you will need to ask me?
No question.
No.
Okay, so if there are no questions, I'm gonna go a little bit more further. Okay, I'm gonna go a little bit more further. What we can also do is we can extend the concept even further. One way we can extend the concept is we can introduce even more, yeah, intermediate variables. Okay, we can have even more intermediate variables. For example, this question here, w equals to inverse of tan xz plus z divided by y. X is equals to t. Y is equals to t squared. And z is shine with a h, t. Okay. So again, chain rule. The first thing, always identify all variables. Yeah. So identify all the variables. So you know, so from the main from the main variable, you know. Yeah. The main function is w. This w is linked to 3 independent variables now: x, y, and z. Yeah. So your main is w. The independence now instead of 2, you have 3. You have x, you have y, you have z. Yeah. And then what is the dependent? X, Y, and Z all related to what? All
T.
related. Yeah, correct. T, right? Yeah, X, Y, and Z all related to T. So now, instead of the tree having 2 branches, yeah, like in the previous question you can see the tree has only 2 branches. Now in this question you have 1, 2, 3, 3 branches. Yeah, so you have to adjust it accordingly. So W with to get to W, so to relate W with X, dW dx. To relate W with Y, dW dy. To relate W with Z, dW dz. Yeah, and then to relate X with T, dx dt. To relate Y with T, dW d. Yeah, so to relate X to T, dW dt. Yeah, sorry, dx dt. To relate Y with T, dy dt. To relate Z with T, dz dt. Yeah. So to get dw dt, it's you just multiply them together. Yeah. So instead of just two trees, now you have 1, 2, and 3. So instead of 2 branches, now you have 3 branches: 1, 2, and 3. Yeah. Okay. So this is this is basically what I'm teaching you here. Okay, and this is the easy part. The difficult part is actually the differentiation. What is dw dx? How do you find dw dx? That is the difficult one. dw dx. Okay, let's look here. How do you find dw dx? Oh, looks difficult. How do you differentiate inverse of 10? Hey, we've done this before, right? Inverse of 10 is arc10. Remember? We've done this before. Arc10. Arc10 x z. What do you get when you differentiate arc10 x z? All right. 1/1 plus x squared. We need to multiply with something, right? So wait, x squared or xz? X squared, right? Oh, right. Okay. What was the formula last time? If quick, Google for me. Arctan x, what do you get? Oh, x squared, huh? Okay. So that means it must be 1 over 1 plus x squared z squared. Yeah. Times d over dx xz. Okay. Tapi belum habis, ah. Ada lagi di belakang. Nih, ada lagi. Z over y. Okay, z over y. Z is because we are differentiating against x. So that means z is constant, y is constant. Dua-dua constant. Okay, that becomes 0. Okay, becomes 0. Okay, and then the whole thing times dx dt. What is dx dt? Well, dx dt easy. X is equals to t. Dx equals to what? 1, right? Yeah, 1. Okay. So now let me color code it, so that easier for you to follow. For you to follow. Let me color code everything. So this is this. Okay. We've only done the first part. Okay. So now we need to do the second one. Plus dw dy. Okay. So differentiate this against y. Well, x is constant. If we do dw dy, that means x constant, z is constant. What does that mean? What do you get when you differentiate tangent, which is a constant inside?
0.
Yeah. Well, sorry, 0 plus. Okay, the next term. Okay, z over y. Z over y. Now, y, z is a constant. Y is something we want to differentiate. So it's like that. Yeah. So what is that? So y you need to bring upstairs. Y to the power -1. Okay? So then dw dy is what? If y is to the power -1. So it's negative. Z is a constant. Y negative 2. Rearrange, you get negative z over y squared. Agree?
Agree.
Agree.
So negative z over y squared. Okay, so this one is red. So this part is this part. Okay. Lastly, plus. No, not finish yet. I'm supposed to multiply by dy dt. Forgot dy dt. Okay, dy dt is what? 2t lah. 2t, right? Yeah, this one is 2t. Okay, and finally, we go back to w again. This time z is the variable, x is the constant. Okay, so same. Arctan, so 1 over 1 plus x squared z squared. But this time, we are differentiating against z. Okay. 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 And then this one, if we differentiate against z, y is a constant. So differentiate z, so 1 over y lah. I think. If I'm wrong, you let me know. Okay. A plus. The whole thing multiplied by dz dt. If z is shine t, what is dz dt? What is shine t? Can you Google? What do you get when you differentiate sine with a h at the back? T.
Cos HT.
It's just cos t. Yeah. Okay. So there. Okay. So therefore, let's solve this. 1 over 1 plus x squared z squared times this. Differentiate against x. That means if we differentiate against x, x becomes 1. So we are left with z plus 0 times 1. Okay, we're left with that. Then negative 2tz over y squared. Okay. Wait, let me color code. I forgot to color code just now. Okay. This last term is this one. Okay. So this is green. This is the red, and the blue is x over 1 plus x squared z squared. That 1 over y, I forgot. 1 over y times cos t. Okay, this is the blue part. Okay, like that. Is that clear? Is that okay, everyone?
Okay.
Yes, doctor.
Now, so this is one way of extending the concept. Yeah. So one way of extending the concept is more intermediate variables. Now, there's another way of extending the concept. Okay, you guys are gonna get so confused here. One more way is more dependent variables. Okay, so example of this is, let's say, yeah, like this. W, x and y. Yeah, so So I'm not increasing the number of variables here. Yeah, I'm not increasing the number of variables. I'm not increasing the number of independent variables, but rather, now previously it's like that, right? Previously it's like that, right? There's only one dependent variable, right?
Yes.
So what I'm doing now, I want to increase the number of dependent variables. So what's actually happening now is I want two independent variables. So not just t, I want two, maybe u and v. U and v, two independent variables. So then what happen is the tree branch gets separated even more. Okay, more dependent variables. So therefore, your full derivative would be dw dx dx du dx dv, and then the bottom part dw dy dy du dy dv. So therefore, if you increase the number of dependent variables, you actually increase the number of possible solutions. Now, instead of previously only one solution, now you can have two solutions. The more dependent variables you have, the more solutions you have. Yeah, you can have two possible solutions now. Okay, so I want to just reiterate with you. Yeah, you go back here. See this. So in the previous example, we only have one dependent variable, only t, and we start from w, we finish at t. Yeah, so if there's only one dependent variable, there's only one possible solution. dw dt, only one. Okay. However, when your dependent variables increase, here we have two independent variable, 1 and 2. Therefore, the possible solution also 2. Okay. So if you increase number of dependent variables, just watch out. The number of solution will increase. You're going to get two solutions. Okay. dw du will be dw dx times dx du plus dw dy du. Yeah. So I'm going to use color again. So this plus this is one solution. Yeah. Yeah. And then dw dv dw dx times dx dv plus dw dy dv. This is another. You're gonna use red color here. This is gonna be another solution. You can see dw dx times dx dv dw dy times dy dv. This is another solution here. Okay. Yeah. So two possible solutions. Give me a second. Okay, so I just went over to look at the test question for this part to see how far I have to go. I don't want to make it too complicated for you. Actually, I can go even further. There's actually a lot more other possible iterations that you need to consider, but I'm not going to go that far. I don't want to confuse you. Okay, so let's go as far as here. Okay, so this is when I increase number of dependent variables, the number of solutions will increase. Okay, so let's do an example related to this one. DW. So let's do an example. W is equals to x cubed plus y cubed. X is equals to u squared plus v squared. Y is equals to 2uv. Yeah. So the way for you to solve this is, you can see, yeah. Previously, I am going to go back to the previous question. So previously, you can see x is related to one variable only. Y is related to one variable only. Z is related to one variable only. Yeah. So x, y, z is both related to t only, one variable. But now you can see x is related to u and v. Y is related to u and v. Yeah. So x is related to two variables. Y is related to two variables as well now, which is why when you draw your tree, your intermediate is x and y. Yeah, because w. How do you know? How do you differentiate your intermediate and your whatever? Yeah, I'm going to use color code here. So w. Yeah. So w, you can see here, w is related to x and related to y. So that's why w, you need to link it to x. Sorry, the blue color, not a nice color. Yeah, w needs to be linked to x and y. X, y. Yeah, and then x is related. I'm going to use green. So x here is related to u and v. Hence, x, you need to relate it to wait. U and v. Similarly, y is also related to u and v. Hence, your y in your tree also has to be related to u and v. Is that okay? Do you know how to draw this tree? If this tree is very important. If you cannot draw this tree, you cannot come up with this solution. You don't know. You're not gonna know how to come up with this solution. You need to know how to draw this tree. Do you know how to draw this tree? It's actually very easy. You just have to look at the question. You can see here the first function, w is related to x and y. Yeah, w related to x and y. That's why my w, I branch it out to x and y. If there's a z in there, then you branch it out further, put another z. if there's a z lah. But in my case, the question there's no z, so you just ignore the z. Okay, so w is related to x and y. That's why w, you branch out to x and y. Next, x. X is related to u and v. That's why you have to branch out from x, you have to branch out u and v. Y also related to u and v. That's why y in the tree, yeah, x, y have to branch out to u and v as well in the tree. Is that clear?
Yes, yes.
Okay. Therefore, if I give you this question, I will ask you to find. My question will be find both what? Both what? Well, they call it partial as well, actually. Yeah, find both partials. So what you do then is simple. Now, once you've drawn a tree, it's simple. Okay, so to relate w with x, it's, well, dw dx. To relate w with y, dw dy. Okay, and then to relate x with u, dx du. To relate x with v, dx dv. To relate y with u, dy du. To relate y with v, dy dv. Yeah. So how many possible solutions would you have? You can know. You look at the last row here. How many variables do you have? You have two variables. You have u and v, two variables. If you have two variables in that last column, that means you have two possible solutions. Yeah, if you have two variables, you have two possible solutions. So the two possible solutions is r dw du and dw dv. Okay, so what is dw du? Well, I'm going to use color again. Okay, so dw du, you look at the u part. This is u, that is u. So you draw a circle, you link everything with the u together, and then link everything with the u together. Those are the u parts. Those are dw du. So it's dx, dw dx times dx du. Plus the bottom one, dw dy times dy du. Okay, so this is u. Then you have another solution, dw dv. So dv, the same. dx, dw dx, dx dv, dw dy, dy dv. I'm gonna use color. Okay. There. Is that clear?
Yeah.
So, can you solve this on your own? Easy. This one easy. Nothing funny about the differentiation. W equals to x squared, x cubed, y cubed. This one you can differentiate easily. X equals to u squared plus v squared. Very easy to differentiate. y equals to 2uv also very difficult, very easy to differentiate. So you should be able to do this, solve this on your own. Try to solve this on your own, get the final answer. The final answer is this, but you do it on your own. 6x squared u plus 6y squared u for the first one, and then 6x squared v plus 6y squared u. Okay, for the second answer. Okay. This one easy, I'm not gonna do for you. All right. I'm basically the part that I'm teaching here is how you draw the tree and then how you come up with these equations to do the partials. Okay. Next. W equals to x tan inverse y z. X equals to u to the power half. Y equals to e to the power negative 2v. Z equals to v cos u. Okay, how do you draw this tree? So again, the first step, we will see W is related to how many variables? W related to how many variables?
3.
3, yeah? So W is related to 3 variables, x, y, z. Yeah, so x, y, z. Okay. Next, x. X is related to how many?
1.
Simple. Y is related to how many?
1.
Also 1, right? V, right?
Yes.
Z is related to how many?
2.
U and V, right? Yeah. V and U. Yeah. There. That's how you draw the tree. Is that easy?
Yes.
Yeah, easy,
Yeah.
right? Okay. So next. How many possible solutions can you get? If I say find all partials, how many? I'm saying find all, but you need to know exactly how many is all. Could be 1, could be 2, could be 3, could be 4, could be 5. You need to know. Yeah. So you need to ask yourself, how many partials are you expected to work out? So to know how many, so to find all partials. So my question is find all partials. Now, to know what the partials are, you need to know exactly how many you have. Yeah. I'm asking you to find all, but I didn't say how many. So you're the one who needs to guess how many partials there are. So the way to find how many partials is, again, look at the last column. In the last column, how many different variables do we have?
2.
2.
2 only, right? Yeah, only 2. Only 2 variables, which is u and v. Therefore, you have 2 solutions or 2 partials. or two partials. Okay. You have two solutions, two partials. Okay, so now let's fill in the tree. So d so from w to x, dw dx, w to y, dw dy, w to z, okay. Now from x to u, y to u, and then z to u, and then z to v. Okay. So we know there are two partials. One of them is u, one of them is v. So therefore, you have two solutions. dw du and dw dv. Yeah. So the number of partial is related to the last row, the last column, the variables in the last column. If you have u and v, that means you're gonna have one solution for u, one solution for v. Simple as that. Okay. So what's dw du? Again, you just have to link anything with u at the back. You have to include. Yeah. So rather than use the circle thing, I'm gonna better use tick. Better use tick. Yeah. I'm gonna use tick to show you which of the variables I'm taking into account. Okay. So now we are looking for dw du. Now we are looking for dw du. So we have a u here. So we need to take this. We have a u here. So we have to multiply with this. We also have a u here. We have to multiply with this. So there's three things to multiply. dw dx, dx du, dw dy, dy du, dw dz, dz du. Okay. Okay, is that clear? Do you know how you come up with this?
Yes.
It's basically all the ones that I underlined using the green color. Okay, all the ones that has u. Okay, next.
Sorry, doctor.
Yeah.
dy over du. How did you get it?
dy over du there. Oh yeah, correct. It's v, right?
Yeah.
Correct. Yeah, well spotted. Correct. You're right. So we don't have. There's no y because it's v. It's v. That doesn't exist. Well spotted. Thank you, Hussein. So for the next test, I will give Hussein extra marks. Thank you.
Thank you, doctor.
Okay, yeah, so correct like that. Yeah, because that one is V. So yeah, I mistake. So that is not U there. Correct, yeah? That is V. That's why I confused myself just now. Change, yeah? It's dy dv, not dy du. Okay, change that one. I made a mistake here. Supposed to be dy dv, not dy du. Yeah, because it's V. Okay. So there. To get dw du, that is the solution. Okay. To get dWdV, okay, I'm going to use green color. No, I'm going to use red color. Okay. So where does V exist? Okay, there's a V here. And there's another V here. Okay. So you need this, you need this. Okay. So therefore, it's dWdy times dWdV. Yeah, dWdy times dydv plus dWdz times dzdv. Okay, yeah, just like that. I use color. Okay. So that you know, green and red. Yeah, you can relate back to the tree. Okay. Any questions? So do you understand how I drew the tree and how I came up with these two solutions?
Yes, all clear.
Okay. What about the others?
Clear.
Clear. Okay. If it's clear, what I want you to do next is I want you to continue. We haven't finished. Now you have to do the differentiation. dw dx. So now you have to look here. You have to look at this. You differentiate against x. Multiply by dx du. So you have to come here, differentiate that against u, and then multiply both together. Yeah, you have to start the multiplication process and get the final answer. Okay. So there's a long step to get the final answer. You have to do. Okay. I just help you to come up with a equation to get the final answer. So now you have to do the differentiation to get the answer. Like what we did earlier. Like what we did earlier. Like that. Yeah. To get the final answer. Okay. So I'll leave you to it. In the next 29 minutes, you can still do it. Okay. So try to do this before end of the class. Okay. I'll let you off now. You can do this. Okay. Make sure you know how to do it. Okay. Get the final answer. Get the final answer. All right. Okay.
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 All right. Okay. Don't leave yet. Need to get your attendance. Wait. Don't leave, huh? Okay, I've shared the attendance in the chat box. Okay, make sure, don't forget, please do it before 12 o'clock. The link will expire at 12 o'clock. Make sure you do the attendance before 12 o'clock today. Don't message